Now this is the project for control labs, then the first partial. This system is a pendulum using a motor with a propeller, so the thrust force can stabilize the counterweight here. And here we have the physical system, the motor, the propeller, the pendulum. We use a potentiometer to measure the angle, and a transporter with this little indicator. Also, here we have the set point. Using these lines, we can know where's the set point. Each line, each division is of 15 degrees. Here we have the proportional, the integral, and the derivative gains. Well, potentiometers to adjust the gains. And this part is the protection for the user, so it cannot hurt. And when we turn on the system, we can start with this sequence. If we shut down all the controls, and this is the on off for the motor, here we have all controls down and on 0. So first we start to modifying the proportional gain. And we turn it on so we can see the action of this control, and we put a little down, and here is stable, more or less. But as we can see, it has some oscillations. If we keep increasing the proportional gain, it oscillates more. But here, if we increase now we can increase the derivative gain, and we can see the oscillations starts to get slower, increase more the gain. And we can put a little bit down the set point. Now that we have some control on the pendulum, here we can see the error between the set point and the sensor we used to measure. And as we can see, it is more or less stable, and the error is almost 0. And to decrease the error, we can move on the integral gain. So if we turn it on and increase the integral gain, we can see how it reacts to erase or eliminate the steady state error. And now we can start moving the gains. Here we have some proportional and derivative. Now we turn off the integral, and it loses the the stability, and the error increases, as we can see here. So now, if we shoot down the derivative, the system starts to oscillate. We can see the oscillations increasing the proportional. If we turn on again the derivative, we can see how the oscillations reduce. And turning on the integral control, we can see how the error decreases too. And this is the first practice for this control. So we can also shoot down all the controllers, and it loses the stability. It's always on the same, it's a constant voltage on the motor. And finally, proportional, derivative, and finally integral. And now we have the right stability of the system. Also, we can move a little bit the set point, and it moves to stabilize the new required point. And that's all. You can. Thank you.